welcoming you all in my teaching demonstration in SCI 119 or Technology for Teaching and Learning. But before we start, I am requesting everyone to please stand for an opening prayer, and Miss Laura May kindly lead the prayer. In the name of the Father, the Son, and the Holy Spirit. Amen. In the Father, the Son, and the Holy Spirit. Amen. Miss Secretary, who is your secretary? Glory Ann. Okay, Glory Ann, kindly check the attendance and tell me who is absent today. Okay, good. You're all present today. Good morning, everyone. Good morning. So let me introduce myself first. I am John Alfred J. Lobaton, your demonstrator for our class today. So our topic for this morning is all about behaviors of gases. So, gas, we have encountered it before, and it's still continuing to exist and become part of our life. Does gas really invisible, or can we really see gas? Yes? No? Actually, when I was in elementary, I've always thought with my teacher that gas is really invisible. It is something that we cannot see with our naked eye, but only we can feel it. But through learning, I realized and I discovered that there are a lot of great scientists who make an experimentations proving that gas has a color. Namely, we have gases like krypton, the neon, xenon, argon, and there are a lot of gases. But through their experiments, laboratory equipment, and careful researches and experimentations, they were able to trap a sample of gas in a laboratory tool such as the J tube, and they found out that gas has a color, and that was actually amazing. I wish that I do that too. Okay, so behaviors of gases. Expect that we will be dealing with the behaviors and its properties. So our learning competencies or objectives include, at the end of the lesson, I am expecting you to first determine the change in the final volume, pressure, and temperature. The second one is investigate the relationships of volume and pressure at constant temperature, volume and temperature at constant pressure, pressure and temperature at constant volume, and explain the above relationships using the kinetic molecular theory of gases. This demonstration is good for 30 minutes, and my resources are as follow. But before we proceed to our proper lesson, let's have a short recap with what we have discussed last meeting. So again, who can tell me what we have discussed last meeting? Yes, Mr. Elmer. Very good. So, chemical reaction. We have discussed about it. And who can tell me what is chemical reaction all about? Mr. Fortunate. Very good. According to Mr. Fortunate, chemical reaction includes the reaction of elements forming a product. That is true. Another one from the girls. Any representative? Yes, Maria Luisa. Okay, very good. So according to her, chemical reaction is a process that takes place involving a chemical changes, which is also true. So when we say chemical reaction, it happens when the reactants effectively collide with other reactants, forming new products. And during this process, what do you call the law being observed? Yes, Miss Isel Torres. Very good. The law of conservation of mass developed by, yes, Mr. Christian. Okay, Antoine Lavoisier. So the law of conservation of mass says that what? Marlo. Very good. Atom is cannot be created nor destroyed. Only it was just rearranged. Or it could be the initial mass of the reactants must be equal to the final mass of the product. So that is the law of conservation of mass, always observed in the chemical reactions. And we have discussed about the factors affecting the rate of chemical reactions. And what are they? Yes, Mr. Janfred. Absolutely, definitely correct. It includes the temperature, the surface tension, concentration, and the catalyst. Aside from hunting and gathering, why do cold-blooded animals such as alligators and reptiles go outside and expose their body under the heat of the sun? Yes, Miss Balberon. Definitely correct. It has something to do with the temperature because what? Rhea. Very good. It has something to do with the temperature because it helps them to increase the rate of their metabolism. Which substance will be dissolved faster? Rock salt or an iodized salt? Nico. Of course, definitely the iodized salt. Why? Christine. Yes, definitely correct. It is because iodized salt has a smaller surface area compared to the rock salt. And that's the reason why iodized salt can be dissolved faster compared to the rock salt. Another one is a liquid nitrogen when left open in a closed room and then a few minutes elapsed, you have noticed that the smell of the room is like a nitrogen, which is actually poisonous or toxic in our health. What do you think is the reason? Yes, Miss Marifer. Okay, correct. It has something to do with the concentration. And last, what do you call the enzymes that are responsible for the fast metabolism in our body? Jen Ann. Of course, it has something to do with the catalyst. It increases the rate of metabolism in our body. So we are done with the review. So let's have a game first. Are you all excited? Group 2, are you excited? How about group 1? Okay, shall we start? So, our game is entitled Name It to Win It. I certainly familiar. Yes, it is familiar because I just based it to the game of It's Showtime. So, name it to win it. So, this will be the group 1 and this will be the group 2. So listen, this is the mechanics of the game. I will be flashing 5 pictures for all. And then group 1 will assemble here and group 2 will assemble here respectively. Count off from 1 to 2. Go. Okay, assemble. So I will be flashing 5 pictures with clues and symbols. And you're going to guess what is the word being indicated in the PowerPoint presentation. Okay, this is gonna be happen. And a representative from the group will go in front to press the digital pressing button so as to let me know who representative comes first. and the team who can have a highest score shall be declared as winner. Okay? Relax, be ready, and breathe in. Okay, let's start. Good. First picture. Tell me the word or group of words. From group 2, Christian. A gravitational force. Some more answer. Christine. Okay, very good. So this is temperature. What do you call this one? A temple, right? Minus LE, temp. Applier, minus PLI is earth, so temper. How about the third symbol? What do you call that? At. So temperate, and pure minus P is yours, so temperature. So 1 point for group 1. Okay, let's write it on the board so that we will not be able to forget it. Group 1 is 1 point. Next picture. Yes, Glory Ann from group 1 again. Vapor, that's not vapor. Sorry. Some more answers. Yes, from group 2, Jed Ann. Very good. This is pressure. Press plus U, and this is color red minus D, so red. Thus, pressure. 1 point also to group 2. Third picture. La 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 la. Yes, from group 2, Michael. Absolute temperature. Some more answer. Yes, Lyra from group 2 again. Kelvin scale. Some more. Marifer rather. Very good. Boils law. But you call this process when water is heated and there was vapor coming out from the kettle. So boiling, so boil, plus S boils. And who's this girl? Si J-Lo. So Lopez minus PES is low, thus boils low. 1 point to group 1. Fourth picture. Michael. Very good. This is volume. And the last picture. Isel. Ideal gas law. Some more. Glory May. Okay, very good. This is ideal gas. So 1 point to group 1. So our winner is group 1. Your prize will be given afterwards. So what is kinetic molecular theory of gases? You have encountered it before, right? In your high school or even up in your college. What is your understanding about kinetic molecular theory of gases? Yes, Miss Lyra. Okay, very good. It is a theory explaining the behavior of particles, wherein in a hot body or hot object, particles in it move faster and thus have a greater kinetic energy and thermal energy, leading to thermal expansion. Take a look at this picture on the right side. Once a body is heated by the fire or heat coming from the sun, the particles in it move faster, colliding each other, pass through each other, and moves vigorously. So that is kinetic molecular theory of gases. So I will give you 3 minutes to reflect on kinetic molecular theory and share it to me afterwards. Okay, go. Your time starts now. 1 minute. 30 seconds. Okay, Christian, share me what's your thoughts. Okay, prior to kinetic molecular theory, there was an existing theory. That's true. Are you familiar with the caloric theory? So caloric theory is a theory developed in the 18th century which says that a hot body when heated, there was an invisible fluid added to it called the caloric. Try to rub your hands, guys. Just rub, and rub. What do you feel? Do you feel cold? Absolutely not. You feel hot. Just continue rubbing your hands. Caloric theory says that when an object is heated, it expands. Huh? Hey sir, hindi ko na pag-i-rub ako niya hands. Basi magdako. Actually, that was a failure made by caloric theory. And after that, there was a kinetic molecular theory proposed newly by the scientists which explains better than caloric theory. Because according to kinetic molecular theory, particles in a body when heated moves vigorously, it moves vigorously, it collides with each other and pass light through each other. And this is the best theory used to explain when a body is heated. So since we're talking about the behaviors of gas, we will be dealing with the ideal gas. From the term itself, what comes to your mind when we say about ideal gas? Mr. Marlo Boleche. Yes, exactly, precisely. When we say ideal, actually it is a gas which is actually ideal. No, it is ideal. It is theoretical, hypothetical, which follows some theorems of a gas. So mathematically descriptive, and there was a mathematical description linked to this, and this involves the relationship of the volume and pressure at constant temperature. So what do you call this law? So it is called the Boyle's law. What is your own understanding about Boyle's law? Yes, Michael. Very good. The volume is inversely proportional to the pressure when the temperature remains constant. So example, I have a balloon here. And then I will compress. Try to hold the balloon myself and compress. John Fred, try to hold the balloon and compress. Okay, what happened to the volume of the balloon? Yes, it decreases. How about the pressure? Does it increase? Okay, no, it decreases. Because according to Boyle's law, volume is inversely proportional to the pressure. What do you mean by the word inversely proportional? So it simply means that it is not equal to. So if I compress the balloon, the volume decreases while the pressure increases and vice versa. So that is Boyle's law. Did I require you to install Notepad, digital Notepad? Okay, good. So to solve mathematically, V1 times P1 is equal to V2 times P2. So using your notepad, okay, now get your cell phones or tablet, open your digital notepad, and answer the sample problem. I will give you 1 minute. Kaya na. So your time starts now. V1 times P1 is equal to V2 times P2. Done? Okay, let's solve. First, let's look what is being asked in the problem. So here, it asks the final volume for the V2. So, and we have to determine what is given in the sample problem, right? Okay, so give me the given. V1 is 0.50 liter. P1 is 1 ATM. P2 is 0.33 ATM. And the V2 is unknown. Thus, this is what are we going to do at. So solution. V1 times P1 is equal to V2 times P2. What are we going to do or add so that we will be able to cancel out the P2 and the V2 will remain? So let's add P2 on both sides so that we will be able to cancel P2 here. So cancel, cancel. Papanalo P2. So V1 times P1 over P2. Do you have the same formula? Okay, very good. So let's substitute. Pila ang values ng V1? 0.50 liter times P1, 1 ATM over P2 pila? 0.33 ATM. So V2 is equal to pila? What's your answer? Okay, very good. So 1.5 liter. Okay, that's good. So at this juncture, this is group 1 and this is group 2. And I have here the pictures. This is related to Boyle's law, a lungs and a syringe. Group 1 or set A will brainstorm or you will have a group discussion. And later on, you will share that to me. So this is your lungs, and group 2 is, this is your syringe. 30 seconds. Your time starts now. Okay, from group 1, who wants to share? The heart. Yes, Christian. Okay, very good. Volume is inversely proportional to pressure. According to Christian, when they inhale, the muscles in the thoracic cavity as well as the lungs expand. But when they exhale, the muscles and the lungs contract. That is true. How about the group 2? Yes, Isel. Okay, very good. So according to her, in order to determine the volume and pressure, they obstruct the passageway of air in the syringe. There is a punta. So what they do is they push up and down the plunger. As they push down, the volume decreases, the pressure increases. But when they push up or pull the plunger, the volume increases while the pressure decreases. So that's it. Question in regards to the Boyle's law. None? Okay, let's proceed. Another mathematical description linked to the volume and temperature. And what do you call that law? Glorian? Yes, exactly. That is Charles' law proposed by Jacques Charles. So what does this mean? Sorry. Leslie May. Very good. So according to Leslie, the volume is directly proportional to the temperature when pressure remains constant or unchanged. So when we say directly proportional, it is equal. The volume is equal to the temperature. So example, have you seen the ping pong balls? Did you notice that once the player or a ping pong tennis player, a ping pong player rather, when the ping pong player hit intensely the ball, what happened to the ball? It became dented. It is because the volume of the ball can be easily dented when intense pressure is heated to the ball. So what they do is they immerse the dented ball into the warm water so that the ball will return to its original size. Why? Yes, Nico. Okay, very good. The temperature is observed with the ball, and thus it results to the increase of size of the ball. The ball and the temperature of the water is directly proportional. Thus, we can prove that volume is directly proportional to the temperature. Give me some more examples. Marifer. Very good. Exactly. Definitely. Did you experiment placing a balloon in a hot temperature in cold temperature? Very good, Marifer. Did you try? What is your findings? Look at this picture. During warm temperature, the balloon increased in size, while in cold or in snow area, it deflated. Nagapupus siya. It is because low temperature gives the ability of the balloon to be deflated, while high temperature gives the ability of the balloon to increase in size. That's why volume is directly proportional to the temperature. Give me some more examples. Shaker. Shaker, posible sa shaker. Yes, shaker. Arang malanggali ka. Yes, that's true. Have you observed in the baking factory, ng tinapay, aside from yeast, Charles' law is applicable to this phenomenon. Very good, Shaker. Why? Temperature increases the size of the bread aside from the yeast. And few minutes elapsed, you notice sa mga tinapay, kung nakuha na ang temperature, ang hot temperature, it decreases in size. No? The same as true when you luto itlog. Di ba kung bago siya luto, mahabo. Same as true with a hot dog. Total na gutom na gidman ko. Okay, so as what we can notice, it increases in size when temperature is high, while it decreases when the temperature is low. So that's it. That is Charles' law. Okay, using a Socratic application, I will be giving a link to you. So open your cell phone. I will be sending a sample problem and you will going to answer it. Okay, so this is good for 30 seconds. So I will be sending. Okay, so starts now. Okay, submit it via Google Classroom na lang. Ay, hindi, direct na lang sa Socratic. Kinara mo siya submit. Direct na lang yung submit. Socratic. Okay, are all done? Okay, let's proceed. Another mathematical description is linked to the pressure and temperature. And what they call that one? Christine. Very good. Guy Lossap's law. It is a law developed by Joseph Louis Guy Lossap, which states that When pressure and temperature, when volume remains constant, the pressure and temperature is directly proportional to each other. So equal naman ang pressure sa temperature. So, examples. Give me using your internet, Google or YouTube. Get your phone, tablet, or laptop. Research about Guy Lawson's law so that you could be able to understand more as well as real life applications. Then after that, you are going to share it with the class. So I will be giving you 1 minute. So your time starts now. Okay, are all done? Okay, Glory May, share your examples, real life applications that you researched. Yes, the pressure cooker. The pressure is directly proportional to the temperature. Very good. So the pressure cooker. When volume remains constant, the pressure is directly proportional to the temperature. Try ka magluto at constant volume. The pressure is always directly proportional or equal to the temperature. But you should not open the tapok after niya magbukal. Because so that you could be able to prevent accident. Because there are a lot of people who commit accident due to pressure cooker because of the ignorance. How about Jed Ann? What is your findings? What is the real life applications you searched for? Yes, exactly. An aerosol can. Have you seen an aerosol can? Actually, aerosol can consists of course, liquid. And there was a gas converted into pressure, and this vapor converted into vapor rather. And this vapor clings to the wall of the container. That's why it is recommended to avoid this in extreme temperature. Because what will happen? Marlo, what will happen to the aerosol can when it is put beside or near to that extreme temperature? Like for example, sa sigang, nagbutang ka to aerosol can. Yes, very good. It will inflate because the temperature will be absorbed by the can, and this will result to the explosion of aerosol can. So this activity will have an activity group. This will still in group 1 and group 2. So I will be letting you solve the Guy-Lossach's law. So to solve mathematically, P1 over T1 is equal to P2 over T2. I will be giving you 30 seconds. And your time starts now. So this is the problem. Okay? Alright na? So share it. So given, what did you do? 25 degrees Celsius. Gas is always in Kelvin scale. So, what did you do? Maria Luisa. Okay, you can convert from degrees Celsius to Kelvin temperature. So, what's the equation? Anong ginimon nyo? Degrees Celsius, Kelvin is equal to degrees Celsius plus Kelvin scale. That's true. So show your writings on the board. Group 1 and Group 2. Okay, I think we have the same answer. So 1.35 APM is the P2. And the last one, we have the combined gas law. So what this all about? Combined gas law. Yes? Jessa. Very good. Combination of all gas laws we have discussed. So it is about the integrating of all Boyle's law and Charles' law that will result to pressure and volume of a gas are inversely proportional to each other but directly proportional to the temperature. So to solve mathematically, P1 over V1, P1 times V1 over T1 is equal to P2 times V2 over T2. Who can solve? Who wants to dare? Yes, Michael. So this is the problem. Show your solution on the board. Okay, very good, Michael. Clap your hands to Michael. So I think we got the same answer. So 134 Kelvin. So any question? Any question? Okay, this time, let's have a by-pair activity. This is an enrichment activity. So your pair 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and so on. So I'll be giving you an exercises by pair. Number 1. This is number 2. And this is number 3. So what we're going to do is by pair. You will answer that in a productivity software applications such as Microsoft, PowerPoint, Excel, or depending on you, as long as you can express your answer and send it to Google Classroom. I will be giving you 2 minutes. Your time starts now. Yes, you have to convert centimeter to liter because we're talking about the volume, not the length. Okay? That's actually a metric unit, metric conversion. So done. Okay, submit it to Google Classroom. Don't forget to don't forget not to write your name so that I could be able to identify your work. Okay, are you ready for the evaluation? Are you ready? Okay, let's have a generalization. This is individual. What is ideal gas? Michael. Okay, a gas that is hypothetical, theoretical, and does not follow most of the rules of gas and does not exist in natural settings. Number 2, Elmer. Very good. So Boyle's law expressed the relationship of volume and pressure when in constant temperature. The volume is inversely proportional to the pressure. Next, Glory Ann. Very good. According to Glory Ann, it expresses the relationship of volume and temperature at direct proportionality at constant pressure. Next is Guy Lossac's law. Scheiker. Okay, according to Scheiker, when pressure is directly proportional to the temperature, the volume must be constant. And what about the combined gas law? Nico. Okay, combination of all gas laws. So let's have an evaluation so that I could be able to determine if you have learned actually. Test 1. Get your cell phones, laptop, or tablet. I will be giving this through Kahoot applications. So don't forget to register or log in to your Google Drive so that you will be able to have access on the link that I will be giving. So I will be giving now a link, okay? So test 1, identification. Identify what is being asked. Number one, done. Okay, number two, done. Okay. Let's proceed. Submit. Okay, submit it already because that is test one. This is test two. Multiple choice. Choose the letter of the correct answer. Number one. Number two. Number three. And number four. Last number. Okay, done. Okay, submit. Did you write your name? Very good. And before we end, I will be giving you assignment. Using productivity software applications without plagiarizing, observing social, moral, and ethical values, using Canva app, or depending on you of what kind of online tools or offline tools are you going to answer this. So this is my assignment. Gloria, may please read. Okay, as you accomplish the task, your assignment, submit it via Google Classroom as another assignment. Okay, let's call it a day. Before I end, I would like to say thank you for the time that you've given to me. Thank you for the opportunity that I teach you a lesson. So I hope that you learn a lot. And thank you for your cooperation or participation in this class. I'm so honored and so blessed and so happy because you are here, you listen, and you cooperate attentively. So once again, I am John Alfred J. Lubaton, BS Ed Science 3, and I have spoken. Thank you.